Recording in progress.
Okay, so today's Pico talk is a philosophical one. So we're going to be talking about emergence. Um, and we're basically going to be discussing this taxonomy between these two different types of emergences, strong emergence and weak emergence. And this is a paper by David Chalmers from 2006. So maybe before we start, I'll just mention a couple fun facts about David Chalmers. So believe it or not, his disheveled hair might not be because he's a philosopher, but because he owns a band. So he's the lead singer in his band, the Zombie Blues, or perhaps it's both. But and so David Chalmers, he's famous for formulating this problem of hard consciousness, the hard problem consciousness. He basically sort of constructed this field that's at the intersection of sort of cognitive science and philosophy, and he also works on sort of the philosophy of language. And his background is actually in pure mathematics. So he did in his bachelor's math, and then he studied philosophy and cognitive science in his PhD with Douglas Hofstadter. So in some ways, his sort of views, he works in philosophy, but I think his views are quite sympathetic to sort of what we do in cognitive science and neuroscience. Yeah, so why do we care to talk about emergence? I mean, so we work in neuroscience, and obviously emergence is a very big idea for us.
So can you briefly, what is it?
Sorry?
What is emergence?
Yeah, so we're going to be talking about that in the presentation, right? But
Okay.
it's roughly, so we have these different levels of abstraction in our science, right? So we have at the very bottom DNA and cells, and we kind of work our way up all the way to sort of these system level things in the brain, and eventually sort of minds, cognition, and consciousness. And sort of the idea for doing a presentation on emergence is perhaps we can kind of refine our tools and language in thinking about this phenomenon of emergence, and maybe that sort of clarifies some of our thinking in our research. So I only have less than probably 20 minutes, so I can really just kind of whet your appetite on this topic. And I'm going to try my best to present Chalmers' views. I'm personally not sympathetic to all of them. Honestly, the more I read his paper, the less sense it made, and the more self-contradictory it felt. So yeah, so I'll try my best. And I think don't squint. So one warning I would sort of give everyone is don't squint too hard at the definitions, because then it starts not making sense. So nevertheless, I think even though parts of the presentation will be kind of vague, I think it's sort of worthwhile for us to try and understand this. Okay, so agenda, we're going to talk about these two types of emergences, and then we're going to sort of dissect each of these in turn. So the way we want to understand emergence is it's a relationship statement between two systems, right? So you have system A, system B, and instead of systems, maybe the more intuitive way to think about it is two different sciences. So you have maybe system B is physics and system A is sort of cognition, and you want to sort of say, intelligence is emergent from these low-level physical sort of laws. And so for a lack of a better method, I would just sort of state the definitions on the slide. So strong emergence, when Chalmers says that, he means that these high-level phenomena, i.e. like cognition, arises from low-level phenomena, so i.e. Physics, but is not deducible from low-level phenomena. And we're going to sort of take a look at what these definitions mean in a second. And then sort of weak emergence is where high-level phenomena arises from low-level phenomena, but is deducible. And I think keyword here being deducible, right? So we're going to look at that sort of in more detail. But the idea here is in weak emergence, still these high-level phenomena, they're unexpected given the low-level phenomena. So for example, if you know that protons, electrons attract, it's really hard to see how you get sort of intelligent behavior in animals from just that.
So these systems, you should think of them as systems of explanation.
That's right.
They're both ways of describing the same underlying entity in the world, if you're realist enough to believe they're entities in the world.
Exactly. Okay, so you can call them systems of explanation, or you call them sciences, or something like that.
Sorry, may I ask you a question? On the distinction between arising and actually deducible, because it seems to me that he's like confusing like two levels, the ontological level and the epistemological level. So if it's not deducible, meaning that you cannot explain it, But if it arises, this is an ontological level, so it's a different one. So what does it mean with arising? Is it just a different word for emergency?
Yeah, so I'm actually not familiar with the philosophy jargon, so I didn't know the words you were using exactly. But I think we will basically talk about this in the presentation, and maybe you can clarify later at lunch, what your views are. I think in the paper is a little bit confusing what he means by the two, but we'll try our best to understand it. But yeah, so to understand these two different words, I basically have this matrix here, right? And sort of the main point I want to make here is, I think maybe sort of at first glance, what you might confuse what he's saying with is you might be, he's not saying that basically there's more to reality than just the physics. So that's something, you might associate with spirituality, where you say like there's a soul and that it doesn't obey the laws of physics. In order to, basically simulate the universe, you need both physics and a soul. So that's not what he's saying. So as you can see in this grid, both weak and strong emergence kind of lie within this column of it does arise from sort of low level laws of the world. And so this deducibility sort of means something else. And maybe I'll sort of, again, maintain a suspense and say that we'll talk about in a few slides. So the first maybe sort of prototype of emergence that we want to look, so I'm going to present sort of a prototype of emergence so we have more intuition. So we're working through this presentation. I think many of you have probably seen the game of life. So this is basically a system. This is a computer simulation where basically there's a 2D grid of these cells. And these cells, they're either dead or alive. So if they're black, they're alive. If they're white, they're dead. And this grid is evolving through time. So basically these cells are dying or coming to life. And they do so according to these 4 rules up here. So basically, just to quickly summarize, if the cells are overpopulated or underpopulated around its neighborhood, then it will die. If it's sort of at the golden point of survival, like having 2 to 3 neighbors, it will survive. And then it has there's another sort of golden point where it has exactly 3 neighbors and it will revive. So basically, these are the low-level rules that give rise to sort of high-level phenomenon like this. So for example, you can build a glider. And what I mean by build in this case is basically you're choosing initial conditions for which cells are alive, and you run sort of the laws forward, and then you get something like this. So the structure kind of moves diagonally across the board. So this, for example, would be an example of weak emergence. So the reason we call this weak emergence is because we say basically this high-level phenomena of a glider is deducible from the low-level rules. And unfortunately, Chalmers doesn't really explain in this example like what he means by deducibility. So I'll just try to maybe fill in the holes here. So how I kind of understand is that you can basically find a low-level explanation for how the glider works based on the low-level rules. So this is sort of roughly the intuition for how it's kind of moving across the board. So basically, you're kind of exploiting this concave structure with these 3 cells, and the concave structure is alternating. And then the cells on the periphery, they're kind of aid in sort of in this process of flipping this concavity back and forth. And this is roughly the intuition for how the glider is able to move. So sort of by having this explanation, we can see how we kind of bridged this high-level and low-level phenomenon. And hence we say, the glider is deducible and is weakly emergent.
What makes it an emergent property rather than just exactly what the maths says is going to happen? Like, I mean, it seems like you have to choose your level to say that this is emergent behavior and not just the system itself.
Yeah, so that's a good question. I don't think he provides a good answer to that, but we will come back to it in another example. Okay, so I think the more sort of provocative notion he's trying to push is this notion of strong emergence. And it's provocative because basically he says strong emergence, the only phenomenon he knows of it is consciousness. So it's kind of strange, right? You're kind of picking with this one phenomenon, you're associating with this entire class of what's going on. So so here's basically his definition of consciousness. Again, I think we're not going to scrutinize it. Hopefully you can read it and just get an intuition for what he's trying to say, and then maybe we can kind of move on and work with it. But basically, so a system is conscious when there is something it is like to be that system, when there is something it feels like from the system's own perspective. And a concrete example is your experience of seeing the color red. So now let's tackle this notion of deducibility. So I've kind of just drawn this diagram because, again, I think reading what he says, it wasn't super clear what he meant. But from my understanding, what he's trying to say is basically sort of these high-level consciousness, which he claims is an example of strong emergence. It arises from the low-level system of, for example, physical laws. So that's the arrow I'm showing at the bottom. So in perhaps the generative process of nature, there's nothing but these physical laws generating consciousness. But I think sort of from the perspective of a human observer, and this is something I kind of added into this explanation. He doesn't explicitly make the move to say it's observer dependence, but the way I understand it is if you're a human observer, then basically you can't understand consciousness from only the physical laws. You need something extra. And this extra stuff he calls the psychophysical laws. So basically, yeah.
So, but you can say that for everything, right? It's like how it feels like to be a bat, for instance. You cannot tell that from the physical laws, right? So this is also non-deducible, but you still know that, you know, being a bat is something that is generated from the physical laws, right? Something material. So then you can apply that to every possible kind of phenomenon, right?
Yeah, so it's not special to humans, I think, definitely. But then
because sorry, I said that you meant that he said that consciousness is the only thing that is strongly emerging. That's why I was.
Okay, yeah. So I'm not super sure what he would say, whether a bat is conscious, but I would imagine he would put it on a spectrum of consciousness, and this would still apply. But I'm just guessing. Right. So and his idea here is it's not, so the difference with weak emergence is it's not that it's very difficult to understand consciousness given the physical laws, it's that it's in principle impossible. So that's why you actually need to introduce these extra laws. And sort of his evidence that he gives, and I think this is sort of what you do in philosophy, right? You have these like thought experiments, and basically he says, you can imagine if there's a colorblind scientist and he's given sort of complete physical knowledge about the brain. He's still unable to deduce what it's like to have a conscious experience of the color red, right? And this is why when I read this, it seems sort of like observer dependence because he's talking about an actual scientist. And the second sort of piece of evidence he gives is that, just to quote him, because it's logically coherent in principle to have other worlds where consciousness doesn't exist, people are not conscious, or conscious experience is different. And in these different worlds, a system physically identical to me might have no consciousness at all. So I'm not super sure what he means. I'm not sympathetic to this view, perhaps due to a lack of imagination on my part. I can't really imagine how you can have these different universes where basically you have same physics that's causing the same consciousness, the same sort of like mind and cognition, but somehow your consciousness is different. But basically, if you sort of accept his assumption, so you can imagine you have these different worlds, right? And everything from the physics to the cognition is the same, but then the consciousness is different. So then you can imagine there's sort of an extra degree of freedom between these different worlds. And that degree of freedom is then constrained by these extra laws he's proposing.
You're sort of begging the question though, right? Because you're saying that you have to assume that consciousness is something that can't be explained from the physical processes in order for you to say that you could have something with the same physical processes that does or doesn't have consciousness. I don't see how you can ever ground that.
Yeah, so I'm not sure logically how coherent in principle means. Like that seems to be the foundation of his argument, right? But right. So okay. So maybe for me, maybe my own personal interpretation is that another way to kind of think about this is basically the experience of seeing red is not sort of reducible, or you can't explain it in a different way. So, for example, with the glider, we can kind of break down this explanation from the high level into sort of these low level concepts and like look at the math. But with the experience of sort of seeing red, you can't just say, you know, a 700 nanometer wavelength hit my eyes and was processed by my brain. That somehow like misses the essence of this experience. So I think that's kind of what he's saying. But yeah, so unfortunately, strong emergence is sort of the confusing part of what he's talking about. But there's also some very interesting ideas from sort of his discussion of weak emergence, which is more sort of relevant to what we do in science. So now we're kind of looking at this notion of unexpected. So what does it mean in work so you only have weak emergence if the high-level phenomenon is unexpected. And what does it mean to be unexpected? So connectionism or sort of deep neural networks are, it seems like they're sort of one of Chalmers' favorite examples of emergence, of weak emergence. And the reason he likes sort of deep neural nets as an example of emergence is because he defined these sort of low-level rules about how the neurons interact with each other. And then you get emergent phenomena. So for example, here you have like edge filters, you have like at levels of the neural network, tire filters or door filters that eventually sort of help you classify a car.
Sorry. And how does he address the fact that a lot of people in the field like struggle to explain why deep learning works in certain instances? Like, doesn't that go against like the weak emergence definition that it has to logically make sense or something?
Yeah, so the idea is the keyword in principle. So he says weak emergence is emergence that is deducible to by the low level in principle. So like assuming you have like almost infinite time and almost infinite like sort of compute and space or whatever. So like I would guess what he would reply to that is, you know, like even though we don't currently understand it currently, we can't explain these nets currently. Maybe at some point in the future we will. Or yeah.
And how does that definition? How can we not extend that to consciousness as well? Like, given enough time, scientists will come up with a theory that will intuitively make sense.
Exactly, it was also my question.
Yeah, so that's a good question. And I think it ties back to his claim that it's logically coherent in principle to imagine different universes where you don't have consciousness, but you have the same sort of like cognition. So maybe I'm not sympathetic enough to his view to actually defend it in this case. I don't know what else to say.
How do we? I put the other complaint with this the other way around, which is now that people since 2012, people now expect these networks to work. So how, in what sense is it unexpected that they are capable of doing object recognition?
Yeah, I think yeah. So as we will sort of look at in the next couple of slides, I think it's unexpected if you kind of throw out the knowledge about the high levels stuff to begin with. So if you just start with the low level and you haven't seen what the high level looks like, you then see the high level, then you get surprised by it, I guess.
But then, but in the end, it becomes unsurprising, right? Unexpectedness is a function of what you're capable of expecting, right? So you could have thought harder. We could have thought harder and then done deep nets before, right?
Yeah, that's right. So it's tricky. So it's tricky. As we'll see, yeah, I think that there's some problems with this framework.
Can I ask another question? How is it emergent?
How is it?
It isn't like assuming that you have the definition of how a deep network works. It's doing exactly what it's designed to do. There's no like emergent property of being able to recognize that car as a particular car. That's what you've designed the system to do.
Yeah, so maybe the output is not as unexpected or emergent, but then sort of intermediate representations are, right?
Are they?
I think
Isn't that why they're there?
Let's maybe let's move on and return this discussion at the end because he does address some of these questions. So as we sort of already brought up, if you can just tell the emergence from the math, is that's really emergence. And so David Chalmers, he's kind of unhappy. This is the best picture of unhappy Chalmers. So he's quite unhappy with calling XOR gates emergent. So XOR gates, they basically have this like logical mapping between input outputs. And you can build XOR gates from 4 NAND gates. So that's what I've shown here at the top. So the whole box is an XOR gate, and then each component is a NAND gate. And that has some other sort of logical mapping. And so he's very unhappy with calling like a system like XOR gates emergent. And the reason being, it seems to fail to capture this feeling of like getting something from nothing that we got from the neural nets and getting these like filters. Even though sort of XOR gate is this higher level sort of new phenomena, right? So So basically, the move he tries to make here in order to kind of remedy the disagreement with his intuition is he says that the emergence is observer dependent. So you know, what is unexpected depends on the observer, and then given that it's observer dependent, emergence only occurs under two conditions. So one, this halo phenomena needs to be sort of interesting to the observer, and two, the halo phenomena needs to be difficult for the observer to deduce from the Lolo phenomena, i.e. the math. Right, so here it's basically too easy to deduce from the NAND gates how an XOR gate would work. So hence this is not does not count as weakly emergent. And of course the problem is like, where do you draw the line, right, between for difficulty, or for it's too difficult to deduce.
Sorry, does observer dependent imply that without an observer there is no emergence?
Yeah, so I think that seems like another rabbit hole to go down, but maybe roughly yes, yeah. So another sort of case where he's sort of unhappy is with calling sort of what's called traditional software, like i.e. software without learning, I think, emergence. So, and the reason here is, well, again, you're not getting something from nothing. Anything that interesting that happens in your computer system is basically coming from you writing it into this high-level code. And then the complex structure at the low level of transistors merely just executes what you're writing.
So bugs are emergent. You didn't expect them.
What is emergent?
Bugs.
Bugs.
So bugs are the only emergent phenomena in regular software.
Yeah, that's right. That's right. Exactly. Yeah, that was actually one of my examples for like where there's actually emergence here, right? Yeah, it's quite unfortunate, but yeah. Right. So you can kind of intuitively see how this is different in flavor from neural nets and Game of Life, right? And so Chalmers sort of makes another move here to solve this problem, and basically what he says is that in order for emergence to occur, the low-level dynamics have to be simple. Whatever that means. And he basically tries to generalize this intuition and to say that something's weakly emergent if it's unexpected with respect to the underlying principles of the system. So basically here the move is to make emergence not only observer dependent, but also to make it sort of reference system or underlying principles dependent. And in this particular example, underlying principle means sort of the design of the system. So yeah, so the function of your code is sort of quite expected from the design that you've injected into the system, and therefore it's not emergent. So yeah, just to summarize, we're trying to understand what unexpected mean in this definition of weak emergence. It's basically a combination of hard to predict from the low levels and unexpected with respect to the design. And these two moves kind of encapsulate the notion of making it observer dependent and then sort of like principle or design dependent. And then, yeah, so some concluding thoughts, and then maybe we can spend 2 minutes discussing. So overall, I thought the paper raised a lot of interesting ideas to think about, although some of the solutions were sort of unsatisfying to me personally. I think the ideas of running simulations of the world and compression and representations seem quite relevant to the discussion, but somehow were sort of missed. Right, of course, like bugs, right? So that seems to be emergent, as Peter pointed out in our code. And then sort of maybe an interesting sort of question to ask is, if there were aliens looking at traditional software, would they think it's emergent, right? If they only had access to the transistors and not the high-level code. And you don't even have to go that far. You know, if your colleague came to you with a computer and you can only look at the transistors and you don't know what the code is, like you would think, maybe you think that's emergent. And that's kind of related to the notion of like human designing and human coding things versus like evolutionary designs. So in the same sort of sense, why is the brain emergent and the computer not, if you only have access to neurons and transistors? And then, yeah, and just a link to a video of him playing rock music. Oh yeah, so maybe if we still have remaining questions, you can come back to it now.
I'm sorry. It seems to me that the way he defines emergence and like conditioning it on observer makes it a cognitive phenomenon rather than like a physical fact about the universe. So, for example, XOR might not be even emergent for us, but what about chimpanzees? Like, is it from the perspective of a chimpanzee weakly emergent system? It's like it just was very unclear to me. Like, does he imply that there are emergent things in the universe, or is it just like is it just a side effect of a cognitive system trying to build a model?
So I can say something, but has anyone actually read his work and have an answer to that? Or
No.
okay, well, so I don't know. Maybe my own view is that I think any intelligent system would have some notion of emergence, but the levels they see will maybe different, based on, I guess, the complexity of their computation or something like that. So I personally do think it's agent dependent. Yeah.
Which then like makes the whole weak versus strong not that interesting of a question, right? Because
So the interestingness for him comes from this, right? Comes from the notion of having like extra laws you have to add in. So basically with weak emergence, you never have to add anything other than like sort of physics to understand things. But given you have sort of long enough time and compute or something like that. But with strong emergence, like even if you had infinite time and compute, you just don't have a chance of understanding it without adding some extra rules.
I agree with Turan actually that there is a confusion between that was the two levels I was talking about, the epistemological level, meaning like the cognitive kind of aspect of the problem Turan was talking about, and the ontological problem, like the how things are. What is very hard is actually to describe how physical properties can emerge from atoms, for instance, right? Like the physical property of being liquid is something that doesn't exist in the macroscopic world, right? But it exists in a more macroscopic world, right? This is harder to somehow explain. But in a sense, I also wanted to make like a connection with Richard Sutton's paper that we discussed a couple of months ago, I guess, this reward is an alpha kind of paper, where he described intelligent behavior, right, as somehow emerging from a very general value function that, you don't need to somehow hard code the different kind of value function for the different objectives. And in that sense, right, intelligence as defined by Richard Sutton might be in that sense a emergent property from an artificial agent. What do you think about that?
Yeah, no, I think that sounds basically right. And one of the points Chalmers tries to make in his paper is that the word emergence is sort of a suitcase word, right? It can mean a lot of different things. And arguably we could, put both the XOR gate and programs into the suitcase of emergence in maybe a sort of slightly different form, or maybe there's continuous axes connecting them. And then sort of maybe emerges from reward optimization. That means something slightly differently, like mechanistically, but yeah, so maybe it's like also emergence, but you might add a couple more details or caveats to what you mean when you say that.
Don't you end up in a situation where everything is emergent if it's observer dependent?
Sorry?
Don't you end up in a situation where everything is emergent if it's observer dependent? Because you can imagine for every bit of knowledge, you could imagine someone who doesn't have that bit of knowledge. And therefore, things that are understandable by everyone else would be emergent to that person. So haven't you just made weak emergence be a property of every single?
So again, I can't really say what Chalmers would say, right? But I mean, like if you're looking at this diagram here, like I think that's basically true, right? So you're the human, you can only do so much with trying to recover the actual truth, and you don't recover the truth. You basically just get a view of the world, right? And every level is basically emergent on what you can see. So.
Okay, well, thank you very much.